Hello students, welcome to the class. So here we have discussed about some basic concepts of chemistry and I have made a small concept map which would cover everything what we have discussed so far. Okay. So concept map I have made some basic concepts of chemistry. What all we have discussed I have just taken them in the form of this flow chart. So in this we have seen what is matter, and under matter we have seen based on physical classification and based on chemical classification, which is also said as at microscopic level and at macroscopic level, right? So at microscopic level we have solids, liquids, gases. Macroscopic level, pure substances and mixtures further being classified as homogeneous and heterogeneous, pure substances being classified as elements and compounds, elements being further classified as metals, non-metals and metalloids, and compounds being classified as inorganic compounds and organic compounds, right? So this is what we have seen here. Apart from that, we have also seen properties of matters, physical properties and chemical properties, which comes under physical changes and chemical changes. Then we have seen the laws of chemical combinations, all the 5 laws. One is law of conservation of mass, Then we have seen law of definite proportions, law of multiple proportions, Gay-Lussac's law, and last what we had seen was Avogadro's law. Then we have seen about stoichiometric significant notation. It is denoted in the form n into 10 raised to n. And then we have spoken about scientific figures, all the rules of scientific figures. We have also discussed about precision and accuracy. Then we come to the stoichiometry and stoichiometric calculations. In that we have seen what are these different ways of expressing the concentrations, might be mass percent, mole fraction, molarity, molality, normality and all. Then what is mole, what is atomic mass, what is molecular mass, what is formula mass, what is gram atomic mass, what is gram molecular mass, and what is atomic volume. Yes, all these things we have discussed in this, and this is a small flow chart, or you can say a concept map to understand all the things. Yes, then with this small discussion, we'll move to the multiple choice questions. Taking up the first question, the dimensions of pressure are the same as that of, the dimensions of pressure are the same as that of. So to understand this, pressure, we know pressure is what? Pressure is force per unit area. So I can say force by area is my pressure, right? Therefore, what are the dimensions of pressure? So how do you write dimension for force? It is force is mass into acceleration due to gravity. So we write m L T minus 2. Yes. So this is force divided by area is what? Length into breadth. So L square. So what is the dimension? M L 1L gets cancelled. So it becomes mass per L per length and T per time square, right? So this is similar for which of the following they have asked. Yes. What is the dimension? Force per unit volume? No. Per unit volume doesn't come. Energy per unit volume? No. Per unit volume, this is square. So what is force? Dimensions of energy per unit volume. The dimension of energy per unit volume is per unit volume, energy upon volume. So energy is again mass L square per time square divided by volume, the liters cubic liters. So what it comes out to be? M per liter per time square. So this and this is same. Therefore, which is the correct option? It is option B. Option B is the correct option. Correct? It is option B. Moving to the next question. Given the numbers 161 centimeter, 0.161 centimeter, 0.0161 centimeter, the number of significant figures for the three numbers. Number of significant figures. So how many significant figures? 161 has got how many significant figures? See, we know the rules. Zeros placed to the left to the number are never significant. Therefore, the number of significant figures in 161, how many significant figures? 3. 0.161, how many significant figures? 3. 0.0161. How many significant figures? Only these three are significant. So option D is the correct option. You should remember all those rules, what the rules say. Yes. Then moving to the next question. Equal masses of hydrogen, oxygen and methane have been taken in a container of volume V at the temperature 27 degrees Celsius in identical conditions. Yes. The ratio of volumes of gases H2 is to O2 is to methane. So what they have asked is, they have asked the ratios of volumes of the different gases. Here, those are not atoms, students. H2 is hydrogen gas. O2 is oxygen gas. Methane, which is also called as marshy gas, it is CH4 gas. So the question asked here is, what is the question asked? The question asked here is, equal masses of H2, O2 and methane have been taken in a container. So equal masses of these gases have been taken of volume V. Its volume is V at temperature 27 degrees Celsius. They have mentioned the temperature because it is identical, because the things occur at same temperatures in identical conditions. The ratio of volume of gases H2 is to O2 is to methane would be. So what is the ratio of the volumes? So see here, which law comes here? So here, the law which comes into context is, according to Avogadro's law. According to Avogadro's law, what does Avogadro's law says? The ratio of equal volumes of any gases at standard temperature and pressure contain equal number of molecules. So according to that law, what I can say is, ratio of the volumes of gases will be equal to the ratio of their number of moles. This is another way of defining Avogadro's law. Equal volumes of gases will contain equal number of molecules. So I can say number of moles is equal to what? Mass divided by molar mass or molecular mass. Correct? So let me take it for hydrogen. Number of moles of H2 gas. Number of moles of H2 gas is, I don't know the mass, divided by what? What is the molar mass of hydrogen? It is 2. Number of moles of O2, I don't know the mass, divided by 32. And number of moles of CH4, the mass is not given. So it is W divided by CH4 is how much? 16. So what is the ratio? Ratio will be W divided by 2 is to W divided by 32 is to W divided by 16. Or I can take the reciprocal of it. 2 is to 32 is to 16. 2 ones are, 2 16s are, 2 8s are. So 1 is to 16 is to 8. Yes. So is there the option? So where 1 is to 16 is to 8. So this is the option. Yes, this is the correct option, right? So it is option C. Next question. What volume of oxygen gas O2 measured at 0 degrees Celsius and 1 atmospheric pressure is needed to burn completely 1 liter of propane gas measured under the same conditions? Yes. So what volume of oxygen gas is needed? So let us see how we can solve it. So they have said, what volume of oxygen gas measured at 0 degrees Celsius is needed to burn completely 1 liter of propane gas? That means this is combustion. This is combustion reaction, correct? So propane gas is subjected for combustion. So propane is C3H8. So propane O2 gives CO2 plus H2O. Correct. So if you want to balance this reaction, please do remember the combustion general reaction. CnH2n plus 2 plus 3n plus 1 by 2 O2 gives NCO2 plus N plus 1 H2O. This is the general reaction. For example, if N is 1, that is number of carbon atoms is 1, CH4 plus 3 ones are 3 plus 1, 4, 4 by 2 is 2O2 gives me CO2 plus 2H2O, like this. So using this reaction, I can balance how many oxygens are required. So C3. So it is C3H8 plus 3 into 3. 3 is 9 plus 1 is 10. 10 by 2 is 5O2 gives 3CO2 plus 4H2O. This is the balanced reaction. So I can write here 5O2, 3CO2, 4H2O. Correct? So this is my balanced reaction. So you should be knowing this reaction. Then it would be easy rather than sitting and balancing the entire reaction. That is the better part, what I feel, I suggest. Okay. So this is the reaction. 1 volume of propane reacts with 5 volume of oxygen to give 3 volumes of carbon dioxide and 4 volumes of water, correct? So according to this above equation, I can say 1 volume, or you can mention it as 1 liter, correct? So 1 volume or 1 liter of propane. The question asked is same. So they have said how much of oxygen is required to completely burn 1 liter. What this reaction I have written is, it is for complete combustion, students. Please do remember. The general reaction what I had written, that is for complete combustion. That means that much amount of oxygen is required to carry out complete combustion. So to burn completely, if I have 1 volume of, that is 1 liter of propane, then how much amount of oxygen is required? So 1 liter of propane requires how much volume? It is 5 volumes, or I can say 5 liters of oxygen to burn completely. Only when there is complete combustion, the products are carbon dioxide and water. If there is incomplete combustion, please do remember, if there is incomplete combustion, then the products will be either CO and H2O, that is carbon monoxide and water, or C and H2O. This is called carbon black, which is used in your shoe paints and all. Yes. So complete combustion, if it has to occur, then what do I need? I need how many? For 1 liter of propane, I need 5. We need 5 liters of oxygen. You have to write the reaction, you have to balance it, and then only you will be able to understand. Yes. Okay. Moving to the next question. 0.24 grams of volatile gas upon vaporization gives 45 ml vapor at NTP. Yes, temperature and pressure, normal temperature and pressure. What will be the vapor density of the substance? The density of hydrogen gas is 0.089 grams per liter. So what is the question they have said? The question what they have said is 0.24 grams of volatile gas. So what is that they have mentioned? It is weight of gas. So what is the weight of gas given? The weight of gas given is 0.24 grams. So 0.24 grams of volatile gas upon vaporization gives 45 ml vapor. So upon vaporization, what is the volume of gas? Because it is ml they have said, no. So volume of gas is 45 ml, milliliters. Okay. At normal temperature and pressure. What will be the vapor density of the substance? See, they have given density of hydrogen in grams per liter. So let us see how we can 45 milliliters. I have to convert it to liters. So divided by 1000, it comes out to 0.045 liters. And what is the density of hydrogen gas? Density of H2 gas is 0.089 grams per liter, correct? 0.089 grams per liter. Therefore, how to solve it? So what is the vapor density they have asked? So what I'll do is, first I'll calculate the weight of 45 ml of H2 gas. What will be the formula? It is density into volume. Yes, these are all derived formulas, students, because density is mass by volume. Therefore, if I want mass, it is density into volume. So what is the density? It is 0.089 into what is the volume? It is 0.045. So what is the answer? You multiply it and see. The answer comes out to be 4.005 into 10 raised to, into 10 raised to minus 3 grams. 4.005 into 10 raised to minus 3 grams. Yes. Then, now we can find, I've got weight, therefore, I can find the vapor density. Vapor density. So, vapor density is nothing but weight of, the formula for vapor density, weight of certain volume of substance divided by weight of same volume of hydrogen. So what is the option? 0.24 divided by 4.005 into 10 raised to minus 3. So when you solve it out, you will get the answer 59.93. 59.93. So this is the correct option. Yes, let us check out where we have that option. 59.93. So the correct option is option B. It is option B, right? Option B is the correct option. Next question. The molecular weight of O2, SO2 are, so the molecular weight of O2, oxygen gas, and SO2, sulfur dioxide gas, are 32 and 64 respectively at 15 degrees Celsius and 150 mm Hg pressure, that is the unit of pressure. 1 liter of O2 contains N molecules. The number of molecules in 2 liters of SO2 under the same conditions of temperature and pressure. Again, the interesting questions, very, very interesting questions this topic has. Yes. So if, let me say, if 1 liter of one gas contains N molecules, then 2 liters of any gas, 2 liters of any gas under same conditions of temperature and pressure, yes, standard temperature and pressure, will contain how many? 2 N molecules. It is like oxygen and SO2, they have said, at standard temperatures and pressures, and they have not changed, equal volumes of any gas at same temperatures and pressures will contain equal number of molecules, Avogadro's law. So here the volume is 1 liter, it is containing N. If SO2 is 1 liter, it will also contain N. If SO2 is 2 liters, it will contain 2N. Yes or no? If it is SO2 is 2N, 2 liters, it will contain 2N. So what is the correct option? It is option C. Option C is the correct option. It will contain 2N molecules. Please do remember it. 2N molecules. Next question. What is the weight of oxygen required for complete combustion of 2.8 kg ethylene? Again, the same question. Yes. 2.8 kg ethylene. See, we should be first knowing the combustion of ethylene. What is ethylene? Ethylene is nothing but ethene. Yes. So ethene, C2H4, CN alkene, CnH2n. Yes. So C2H4 is ethylene. Combustion of ethylene. This requires 3 molecules of O2 to form 2 molecules of CO2 plus 2 molecules. Two molecules of H2O. Okay. So otherwise, if you don't remember that general reaction, you can balance it here only. 2 high carbons, 2 carbons, 4 hydrogens, therefore I write 2 H2O here. Then here, when I write 2 carbons and 4 hydrogens, it becomes 2 to the 4 plus 2, 6. Therefore, I'll balance here by writing 3. So here, look at the molecular mass. Carbon, 12 plus 2 plus 12 into 2 plus 1 into 4. Yes. Oxygen, 2 into 16. Carbon dioxide formed, 12 plus 16 into 2. Water, 2, 1 into 2 plus 16. So total, let me write all the masses. 12 to the 24. 24 plus 2 is 20, 24 plus 4 is 28. 16 to the 32. 32 into 3 is 96 grams. Correct? Then here 16 to the 32. 44. 44 into 2. 88. And here 16 to the 16 plus 2 is 18. 18 to the 36. So let me write all of them. Okay. Now see, the question is weight of oxygen required for complete combustion of 2.8 kg ethylene. 28 grams for complete combustion of 28 grams of ethylene. For complete combustion of 28 grams of ethylene, I am requiring 96 grams of oxygen. Correct? They have asked for 2.8 kg ethylene. How much oxygen is required? So for 2.8 kg of ethylene, for 2.8 kg of C2H4 requires how much? 96 divided by 28 into how many kgs? 2.8. This should be converted to kg, 28. So 10 raised to 3 grams. Correct? So how much I get? 9.6 into 10 raised to 3 grams. Or I can write 9.6, 10 raised to 3 is kilo. So 9.6 kg of oxygen is required. So how much of oxygen is required? 9.6 kg of oxygen is required for complete combustion of. So let us see, for complete combustion of ethylene. So how much? 9.6. That is 9.6. 96 is also given, but 96 is for grams. So here we need 9.6, right? Next question. An element X has the following isotopic compositions. So X, 200 mass, 90%. 199 is 8.0%. 202 is 2%. The weighted average atomic mass of naturally occurring element X is closest to. See, when I was discussing about atomic mass, I have also discussed about the average atomic mass. So how do we find the average atomic mass? The average atomic mass of the given element X. See, what is the formula? Atomic mass into percentage. Or atomic masses, the formula is, I'll tell you, atomic mass into percentage of abundance plus of first isotope, atomic mass into percentage of abundance of second isotope plus atomic mass into percentage of abundance of third isotope divided by total abundance. Yes, total percentage of abundance. So that is the formula. So how do we write it? Atomic mass of first isotope is how much? 200 into percentage of abundance is 90. They have given us. Plus atomic mass of second one is 199 into percentage of abundance is 8. Plus atomic mass of next isotope is 202 into it is 2%. The whole divided by 90 plus 8 plus 2, total becomes 100. So solve it out. 200 into 9, 9 2s are 18, 0, 0, 0 plus 99 into 8, 9 8s are 72, 7, 9 it's a 72, 7 and 7 becomes 9 and it comes out to be 1592 plus 404, correct? The whole divided by 100, right? How much we get? Solve it out. You will get the answer 199.96. And what is the unit? Average atomic mass. It is AMU, or you can write 199.96 unified mass, which is approximately nothing but rounding off we have studied 200 unified mass or 200 AMU, right? So 200 unified mass or 200 AMU. So which is the correct option? The correct option is option D, 200 AMU, or now we can use it as sometimes instead of AMU, they will give unified mass also. Next one. Boron has two stable isotopes. Boron 10 is 19% and boron 11 is 81%. Calculate the average weight of boron in the periodic table. Same question as we have discussed previous. Yes, I will use the same formula. So I can write here average. This is question number 9 if I'm not wrong. Average atomic mass of boron, that is B, yes, is equal to, what is the atomic mass of first isotope? 10 into how much percentage is given? 19 plus second one is 11 into 81% divided by 100. It total becomes 100 always. So it is how much you get? 190 into 11 ones are 11, 88, 89 divided by 100. Solve it out. You will get the answer around 10.81. This is the answer. So what is the atomic mass of boron in the periodic table? It is option A. It is 10.8. Next question. Which one of the followings has maximum number of atoms? See, such type of questions are most expected questions. How to calculate maximum number of atoms? Yes. Okay, let us take examples to solve here. Let us take the same example. Okay, fine. So they have said 1 gram of Ag. Please do remember 1 mole of substance, yes, is equal to Avogadro number, or you can say that is equal to atomic mass, and if it is a molecule, it is equal to molecular mass or molecular mass. Please do remember this. So they have said 1 gram of Ag. And what is the atomic mass of Ag? Is silver. So what is the atomic mass of silver? atomic mass of silver they have given, it is 108. So 108 grams of silver will contain how many atoms? Avogadro number of atoms, correct? Yes. But here they have said 1 gram of silver will contain how many? So it is Avogadro number divided by 108 atoms. Yes or no? Simple formula. Next, magnesium, what is the atomic mass? 24. 24 grams of magnesium if you take, it will have Avogadro number of atoms, magnesium atoms. But here they have said how much? They have said 1 gram of magnesium. So 1 gram of magnesium will have how many? Avogadro number divided by 24 atoms. Correct? You need not simplify it. Let us see. Next, 1 gram of O2. O2 they have said. So 32 grams of O2 will contain Avogadro number of molecules of O2. So here I will say molecules. Therefore, 1 gram of O2 will have how many molecules? Na divided by 32 molecules. Yes. But here I want it in terms of atoms. So I can say 32 for O2. So for Na, contains Avogadro number of molecules. So here I can mention it as 1 gram of O2 will have Na by 16 because 2 O2, 2 Na comes. 2 Na atoms I can write. If I say 16 grams of oxygen, so 2 Na, correct? So here it becomes Na by 16. Na by 16. I will remove molecules and write atoms. Yes. Last one. Lithium. 7 is the atomic mass. 7 grams of lithium contains Avogadro number of atoms. 1 gram of lithium will contain Avogadro number of atoms divided by 7 atoms. Correct? So here, which of them has maximum? Look here, which will have maximum? Na by 108, Na by 24, Na by 16, Na by 7. So where denominator number is least, there will be maximum number of atoms. Therefore, I can say 1 gram of lithium has maximum number of atoms. Yes, hope this question is clear. We'll have maximum number of atoms. So the correct option is, it is option D. You have to solve it in that form. Then only you will get the answer. Next question. In which case is the number of molecules of water maximum? In which case is the number of molecules of water is maximum? See, now they have said same water molecules only. Where it is maximum, you have to answer. So what they have said, 18 ml of water, 0.18 grams of water, 0.00224 liters of water, vapors at 1 atmosphere and 273 Kelvin, or 10 raised to minus 3 moles of water. See, mass of water is equal to vapor volume into density. Density is mass by volume. So mass is equal to volume into density. Yes. So volume of water is 18. Mass of volume of water is 18 into density is 1. So I get 18 grams. Okay. Molecules of water. How to find molecules of water? So that is nothing but number of moles into Avogadro number. That is nothing but 18 divided by 18, because moles, number of moles, I know the formula, given mass upon molar mass, into Avogadro number Na. Correct? So 18 gets cancelled. So it is Na. So how many molecules of water are there? Na. Here only you should understand it, because moles of mass of water and molecular mass is same. Therefore it will have Avogadro number of molecules. This is option A. Option B. Molecules of water is equal to moles into Avogadro number again. So moles here, how many? Have they given us moles? No, they have given us grams. So when I write moles into Avogadro number, They have not given us moles, but I know the amount. So it is 0.18 divided by 18 into Na. Yes, this is the answer what we get. C option. Moles of water. They have given it in moles only, right? 0.00224. 0.00224 liters is given. Therefore, divided by what I'll do? I'll take 22.4 because I have to take it in liters. Yes, that will be equal to 10 raised to minus 4. Therefore, molecules of water. Here also have to calculate. Molecules of water is equal to moles into Avogadro number. That is equal to 10 raised to minus 4 into Avogadro number. Option D. Molecules of water is equal to, excuse me boss, you have a text message, is equal to moles again into Avogadro number. How many moles it is given? 10 raised to minus 3 Na. I hope this point is clear. In the first case, they have given us ml. So I have to convert it to grams. Yes, mass I have to convert. So how do I convert it to grams? Volume, given volume into density. Density of water is 1. So 18 into 1, I'll get 18 grams. Then I can find molecules of water. How many molecules? The formula is moles into Avogadro number. I don't know how many moles are there, but I know the weight and mass of the molecular mass of water. So 18 by 18 into Na, that comes out to be Na. That is Avogadro number. Then molecules of water, moles into Avogadro number. Second option. So moles is being given? No, they have given us grams. So 0.18 divided by 18 into Avogadro number, right? Then, so that comes out to be 10 raised to minus 2 into Avogadro number. Okay, moles of water. Next, third option, they have given us liters. So I have to first find moles and then I will find the molecules of water here. How to find the moles when volume is given? Given volume upon molecular volume, atomic volume, we know, gram atomic volume, 22.4. That comes into Avogadro. This is moles of water. Then find the molecules of water, moles into Avogadro number, 10 raised to minus 4 into Na. Last option, molecules of water, directly moles are given, 10 raised to minus 3 into Avogadro number. So where there is maximum number of water molecules, 10 raised to minus 3 is less, 10 raised to minus 4 is least, 10 raised to minus 2 is less, but this is more. So option A is the correct option. Which is the correct option? It is option A. A is the correct option. Next question. Suppose the elements X and Y combine to form two compounds, XY2 and X3Y2, when 0.1 mole of XY2 weighs 10 grams and 0.05 moles of X3Y2 weighs 9 grams, the atomic weights of X and Y are. See, I have covered almost all the types of questions which will be being asked here. So, let us consider, let the atomic weight of element X, let me say it is small x, and the atomic weight of, or atomic mass you can say, of element Y is small y. Let me consider this like this. There is a compound, they say XY2. For XY2, how do you calculate number of moles? Given mass upon molecular mass, correct? So, number of moles is given when 0.1 mole of XY2 they have said. So, number of moles is 0.1. When 0.1 moles of XY2 weighs 10 grams. So, it is weighing 10 grams, correct? Yes, so it is weighing 10 grams. So, molecular weight. What would be the molecular weight? It is XY2. Therefore, the molecular weight X molecules plus 2 into Y. So, it becomes XY2. Correct. So, I can write this as X plus 2Y is equal to 10 divided by 0.1, which comes out to 100. Okay. So, let me call this as equation 1. For X3Y2, this is another. Number of moles is equal to given mass upon molar mass. How much number of moles they have said? 0.05 is moles of X3Y2 weighs 9 grams. So like how I'll write here? x3. So it is 3x plus 2y. So this can be written as 3x plus 2y is equal to 9 divided by 0.05, which is nothing but 180. Call this as equation 2. So solve equations 1 and 2. It's very clear. Yes. So what you get? 4x plus 2y is equal to 100. 3x plus 2y is equal to 180. So when you solve it out, you get 40 plus 2y is equal to 100. 40 plus 2y is equal to 100. So what will be 2y? 2y is equal to 100 minus 40. That is nothing but 60. Then what is y? Y will be 30. Solve it out. You get, for example, here x plus 2y is equal to 100. Yes. So here x plus 2y is equal to 100. X is equal to 3x plus 2y is equal to 180. So when you solve it out, you get x equal to 40. So if x is equal to 40, then what is y? 40 plus 2y is equal to 100. 2y is equal to 60. Therefore, y is equal to 30. So x is equal to 40. Y is equal to 30. So let us see which option comes out here. 40 and 30. So the correct option is option A. So what I did, I found out the number of moles of X, the number of moles of Y. I took the formula and found out the equations for both of them. And then when you solve the equations 1 and 2, you will get X. Using that X, you will find Y. Yes? Okay. Next question. If Avogadro number Na is changed from 6.0222 into 10 raised to 23 moles per moles to 6.022 into 10 raised to 20 per mole, this would change what? Very beautiful question they have asked. If you change the Avogadro number to this, what will happen? What will happen? 6.022 into 10 raised to 23 per mole to 6.022 into 10 raised to 20 per mole. What would change? Yes. Whenever we have spoken about mole concept, we have considered the isotope of carbon. Okay. So let us see the options. The option A says mass of 1 mole of carbon changes. The ratio, option B, the ratio of chemical species to each other in a balanced chemical equation changes. The ratio of elements to each other in a compound changes. The definition of mass in units of grams changes. See, will the definition of mass in unit gram changes? No. Will the ratio of the elements to each other of the compound changes? No, it says the law of multiple definite proportion says whenever elements combine to form a compound, their ratio remains same. In that case, we will not come across any of the Avogadro number. We'll just speak about how many atoms of different elements are combining. Yes. Option B, the ratio of chemical species to each other in a balanced equation. Will it change? When you're balancing the equation, you will just see how many atoms of a particular element are there on the left hand side and the right hand side. That is on the reactant side and on the product side. So that will not change. The mass of 1 mole of carbon will change. Is it correct? Let us see if that is correct. So obviously that only should be correct. So let us see how, if that is how that can be correct. Mass of 1 mole, we say 6.022 into 10 raised to 23 atoms of carbon. Yes or no? If I say mass of 1 mole of carbon, and that is equal to how much? It is equal to 12 grams. Same, 1 mole is Avogadro number and that is equal to atomic mass. If the Avogadro number is changed to 6.022 into 10 raised to 20 atoms, then what will happen? Then mass of 1 mole of carbon would be what? It would be, here everything is there, you can cross multiply, 12 into 6 point, this comes 6.022 into 10 raised to 20 divided by 6.022 into 10 raised to 23. So what it comes out to? This gets cancelled. 12 into 10 raised to minus 3 grams it comes out. So what gets changed? If you change the Avogadro number, what will change? There will be change in the mass of one atom of 1 mole of carbon. And we saw how the mass changes. Is that right? It becomes 12 into 10 raised to minus 3. Next question. A mixture of gases contains H2 and O2 gases in the ratio 1:4 weight by weight. W by W stands for weight by weight. What is the molar ratio of the two gases in the mixture? So we'll go with the question. So mixture of gases contain H2 and O2. Yes. And the ratio is 1:4 weight by weight. So this is the ratio. What is the molar ratio of two gases in the mixture? 1:4. So number of moles of H2 will be how much? 1 is the weight. 1 weight by weight is 1 gram of H2 and 4 grams of O2. So weight by weight stands for that only. So mass upon molar mass of what? This is 2. Number of moles of O2. So what is the mass? It is 4 divided by O2 is 32. So what will be the molar ratio? Molar ratio will be H2:O2, right? So it is 1/2:4/32. So how much? When you solve it out, it comes to 4:1. Yes, this is the molar ratio. 1/2 is to this. Solve it out, you get 4:1. So let us see which is the correct option here. The correct option is option D. It is 4:1. Yes, 4:1. Next question. Which which has the maximum number of molecules among the following? Is it 44 grams of CO2, 48 grams of O3, 8 grams of H2, or 64 grams of SO2, sulfur dioxide? So they have taken 4 different gases. So which one will have maximum number of molecules? CO2, O3, H2, and SO2. See, what is the molar mass of CO2? Molar mass of CO2 is 44. O3, oxygen, 16 into 3, 48. Hydrogen, 2. SO2, sulfur, 64. Yes, you can calculate. So here 44 grams of O2 will have Avogadro number. 48 grams of O3 will have Avogadro number. 2 grams of hydrogen will have Avogadro number. And 64 grams of sulfur dioxide will have Avogadro number. Option A has 44 grams of O2. So that is Avogadro number. Option B has 48 grams of O3. That is also Avogadro number. Option 3 is 8 grams. So Avogadro number into 8. Correct. Into 8. Option D is again 64. So which is the correct option? It is option C. Because 8 grams of H2 will have how many moles? It will have 4 moles. So 4 into, it is not 8, 4 into Avogadro number it becomes. While the others have 1 mole each. Rest all of them have 1 mole each. Therefore, the correct option is, it is 8 grams of H2. This is how we solve it. The number of atoms in 0.1 moles of a triatomic gas. A triatomic gas is there and they have said 0.1 moles. What is the formula for number of atoms? Number of atoms or number of particles is equal to Avogadro number into number of moles And what is type of molecule? It is triatomic, therefore into 3. If it is diatomic, into 2. Okay. So what is Avogadro number? 6.022 into 10 raised to 23. How many moles they have said? 0.1 into a triatomic molecule 3. Solve it out. You will get 6.022 into 0.1 into 3. So you will get it answer around 1.806 into 10 raised to 23 number of atoms. So the correct option is 1.806 into 10 raised to 23. It is option B. Moving to the next question. The maximum number of molecules is present in when which of the following there is maximum number of molecules? 15 liters of H2 gas at STP, 5 liters of N2 gas at STP, 0.5 grams of H2 gas, 10 grams of O2 gas. So where maximum number of molecules are present? Yes, solve it. When you go do lot many examples, you become perfect in it. Okay, so let us see. So at STP, okay, standard temperature and pressure. What is the condition? 22.4 liters is equal to 6.022, or in some cases it is given 3 into 10 raised to 23 molecules. Okay, for liters. This is gram atomic volume, what we say, 22.4. So first option is, option A is 15 liters of H2 gas. So 15 liters means how you will do it? So cross multiply 6.023 into 10 raised to 23 divided by into 15, the whole divided by 22.4 number of molecules. Solve it out. Second option, they have said 5 liters of N2. Same again, 6.023 into 10 raised to 23 into 5, the whole divided by 22.4 number of molecules. Third option, what they have said, 0.5 grams of H2 gas. Grams they have said. So 0.5 grams of H2 gas. See, 2 grams of H2 gas will have Avogadro number of molecules, because that is the molecular mass, right? Avogadro number of molecules. So 0.5 grams, 0.5 grams of H2 gas is equal to 6.023 into 10 raised to 23 into 0.5, the whole divided by, what I'll write here, 2, correct? Because 2 grams. 2, okay. Last option is also in grams. Therefore, I can say 32 grams of O2 is equal to Avogadro number of molecules, correct? Therefore, they have said 10 grams of O2 will be what? 6.023 into 10 raised to 23 into 10, the whole divided by 32. Yes. To solve it out, this answer comes out to be 4.033 into 10 raised to 23 molecules. Second option, solving, comes out to be 1.344 into 10 raised to 23 molecules. Third option, 1.505 into 10 raised to 23 molecules. And last option, 1.882 into 10 raised to 23 molecules. Yes. So question is, maximum number of molecules is present in. So where maximum number of molecules are present? This is 4111. So it is option It is option A because it is having so many number of molecules. Yes, so the correct option is, it is option A. Same question. Which has maximum number of molecules? 7 grams of N2, 2 grams of H2, 16 grams of NO2, and 16 grams of O2. So which is having? Same question. Yes. So here, number of, that formula you should fix first. Number of molecules is equal to what? Again, moles into Avogadro number, correct? Because formula for moles is what? It is number of molecules upon Avogadro number. From this formula only, I have derived our derived formula, right? Okay. So let us take option A. So 7 grams of N2. So molecules of N2. They have given grams. So moles have to calculate given mass upon molar mass. So given mass is how much? 7 divided by N2 is 14. So all of them are there in molecular level. So it is 7 grams of N2. So it is 14 into Avogadro number. Comes out to be 0.5 Avogadro number. Option B, molecules of H2. So 2, how much you have given? 2 grams. 2 divided by 2 into Avogadro number. So this comes out to Avogadro number only. So this is not 14, this is 28 and 2. So answer comes out to 7 is 14, 7 are 21, and 4 are 28. So yes, 0.25. Next option, molecules of NO2. Yes, how much they have given? 16 grams. 16 grams divided by NO2. Nitrogen is 14. 32 comes out to 46 into Avogadro number. So solve it. You will get 0.35 into Avogadro number. And last option is molecules of O2. So how much they have said? 16 divided by 32 into Avogadro number. So it is 0.5 Avogadro number. So which is the correct option? Where maximum number? So this is maximum number. Therefore, 2 grams of H2, that is 1 mole of H2 contains maximum molecules. Yes. So the correct option is option B. Next question. Specific volume of cylindrical virus particle is 6.2 into 10 raised to minus 2 cc per gram, whose radius and length are 7 angstrom and 10 angstrom respectively. If Avogadro number is 6.02 into 10 raised to 23, if they have given 6.02, you have to use 6.02 only. Find the molecular weight of the virus. Yes, so they have given there is some virus. Its specific volume is, so what is the specific volume? Specific volume, that is volume of 1 gram of the cylindrical virus, is virus particle, is how much? 6.02 into 10 raised to minus 2 cc per gram. Okay. Then the radius and length are given. Radius of the virus is how much? 7 angstrom. That is nothing but 7 into 10 raised to minus 10 meters, or 7 into cc is given, no, 10 raised to minus 8 centimeter. Then length is given. Length of virus is how much? 10 angstrom. Here is 10 angstrom. So how do you calculate volume? Volume of virus is equal to cylindrical, they have said. So pi r square into L. So here angstrom becomes 10 into 10 raised to minus 10 meters, 10 into minus 8 centimeters. Yes. Okay. So pi is 22 by 7 into radius is 7 into 10 raised to 8 minus 8 the whole square into 10 into 10 raised to minus 8. Solve it out. 7 gets cancelled. So what? 7 into 7. So 7 sevens are 49. 7 ones are 7 sevens are 49. So 22 into 7. You will get the answer 154 into 10 raised to 8 twos are 16 minus 16 plus 1 minus 8. How much you get? 154 into 10 raised to minus 23 cc. This is the volume. They have asked you weight. So weight of one virus particle. Okay. So what is the formula I can write? Volume in cc divided by specific volume. Yes. So what is the volume? We have found 154 into 10 raised to minus 23 divided by specific volume they have given as 6.02 into 10 raised to minus 2. So the answer comes out to, we'll keep it as it is, molecular weight of virus. This is weight of one virus particle, but here they have asked my molecular weight is nothing but weight of Avogadro number of particles. So weight into Avogadro number. So how much is the weight? It is 154 into 10 raised to minus 23 divided by 6.02 into 10 raised to minus 2 into 6.02 into 10 raised to 23. Correct? Grams per mole. So this gets cancelled. Minus 23 plus 23 gets cancelled. So I'll get the answer 154 10 raised to 2, 2 zeros. Or I can write this is grams, or I can mention it as 15.4 kg per mole. Grams per mole it becomes. You can convert it to kg. 1, 2, 3. Substitute, shifting the decimal points 3 digits to the left. 10 raised to 3. It becomes kg per mole. So first what we did, we have specific volume given, radius and length is given. So volume of the virus, cylindrical virus they have said. So the formula is pi r square L. So pi value is 22 by 7. Radius is 7 into 10 raised to minus 8 the whole square into length 10 into 10 raised to minus 8. Solve it out, you will get the volume. Why volume is required? To find the weight. So what is the formula for weight of one virus particle? It is volume by specific volume. Volume we have found out, specific volume is given 6.02 into 10 raised to minus 2. By that we get volume of one particle. But they have asked the molecular weight of the virus. So molecular weight of the virus will be what? The molecular weight of the virus will be weight of Avogadro number of particles. So what is weight is there into Avogadro number. So we'll get the answer 15.4 into 15.4 kg per mole. So what is the correct option? The correct option is 15.4 kg per mole. It is option A. Next question. The number of atoms in 4.25 grams of ammonia is approximately. Ammonia is NH3. Ammonia. Okay. What is the molecular mass of ammonia? It is 14 plus 1 into 3. So it is 17 grams. Yes. So I can say 17 grams of NH3 is equal to Avogadro number of particles. Okay. Okay. So 4.25 grams of NH3. This is molecules. So there are how many atoms in this molecule? NH3 molecule has got 4 atoms. Correct? So I have to speak in terms of atoms. This is a molecule. So Avogadro number And how many total atoms? 4 atoms. Therefore, 4Na it becomes. Are you all understanding? I'll take it once again. Ammonia molecule is what? Ammonia is NH3. Okay. It is having total of how many atoms? It is having total of 4 atoms. It is a molecule. What is the molecular mass of ammonia? It is 14 plus 1 into 3, that is equal to 17 grams. So I can speak like this. 17 grams of ammonia is equal to Avogadro number of molecules. Correct? But here what they have said? They have said atoms. So I can say 17 grams of ammonia is equal to, I have to convert it to atoms now. Avogadro number. Total ammonia. Ammonia has got how many atoms? It has got 4 atoms. So 4 into Avogadro number. Understood? Okay. But the question is 4.25 grams of NH3. 4.25 grams of NH3 will have how many? So 4 into Avogadro number divided by 17 into how many? 4.25 they have asked. So solve it out. How much you get? Approximately 4 4s are 16.25 and 17 divided by 17. Almost same. Around 1 we get. So it is Na, number of atoms. So how many atoms? 6.023 into 10 raised to 23 atoms. Option D is the correct option. Understood? So ammonia, if they would have said molecules, you would not use this lead number 4. They have said atoms. So ammonia is NH3, atomic molecular mass we know 17. But ammonia has 4 atoms. 17 grams of NH3 will have Avogadro number of molecules. But I want atoms. So how can I write? 17 grams of NH3 will have 4 into Avogadro number of atoms. But they have asked it for 4.25 grams of NH3. So it will be 4 into Avogadro number divided by 17 molecular mass into given mass 4.25. Solve it out. 4 4s are 16.25 and 7 divided by 17 almost comes out to 1 into Avogadro number of atoms. And Avogadro number is 6.023 into 10 raised to 23. This is the correct option. So with this, we have completed around 20 questions. In the next video, we'll be taking next more questions regarding this topic. Hope you have understood all the questions. Thank you.